Okay, thank you. Welcome. So I'm today talking about leveraging H2O machine learning with KNIME Analytics Platform. But before I start with my talk and introduce KNIME Analytics Platform and actually what KNIME is, Joe asked me to let him give some context.
Yeah. So hi everyone, it's me again, the 360 savvy guy. So I just want to give you context of how H2O can be used within the KNIME platform. So you may know that H2O3, the open source H2O platform, we have different algorithms for both supervised and unsupervised learning. So again, for supervised, we have random forest, linear model, gradient machine. So all this common algorithm that is written in Java, but they're all open source and scalable. So what we want to do now is to look at this chart here. So this is the magic quadrant for data science and machine learning platform. This is not done by us, it's from Gartner. So every year they try to evaluate different companies in this sector, and based on the feedback of customers, based on the functionality of the software, they put different company onto this chart. So you can see the big guys here, IBM, Microsoft, SaaS, etc. And you can also see H2O and KNIME both in the leader quadrants. So the best thing is that KNIME and H2O are both open source. So at some point we know that this will happen because we can put the algorithm from H2O into KNIME, and KNIME can use the platform that they have different kind of nodes to which Kristen will explain better, different ways to munch the data in a graphical interface. And you can utilize that to combine it with H2O, the machine learning algorithm, to make it scalable. So I'm going to let Kristen tell you how we can actually do that in KNIME. Thank you.
Thank you. Okay, so before I start, who actually, I wait a second and then I start. Okay, who actually used KNIME before, or who's a frequent KNIME user? Okay, but some of you don't know what KNIME is, so it makes sense to introduce our company first. So we are a small, not so small anymore company, founded in 2008. It was a spin-off from the University of Constance. Constance is a very small city at the Lake of Constance, South Germany, Swiss border, beautiful. But we figured that we need other places to represent our company, so we have offices in Zurich, Constance, Berlin, and Austin now. We are 70 employees, and we are the maintainers of the so-called KNIME Analytics Platform. And KNIME Analytics Platform is an open source tool, which I will introduce in a second. However, we are a company, so also we want to make somehow money, and we have a commercial product called the KNIME Server and some cloud offerings. So what we do is centered around the KNIME Analytics Platform. As I said, it's open source. You can download it, no restrictions, no limitations. You can play with it today and do whatever you want with it. However, if you download KNIME Analytics Platform as is, you have some basic functionality, but you can add stuff to it. And we have so-called integrations and extensions to our platform. KNIME integrations are basically wrappers around famous or well-known open source tools to provide additional functionality within our platform. Extensions are also providing additional functionality or data types to KNIME Analytics Platform, but they are mainly developed by us in-house. So the most of the code comes from us, and we are not wrapping an external tool. Then we have also extensions stemming from our community. So our community provides those extensions. This can be companies, this can be universities, all kinds of institutes provide additional functionality to KNIME Analytics Platform. We have partner extensions, which are often commercially licensed, and then we have the KNIME Server. The KNIME Server allows you to collaborate in teams, to share workflows. I will explain what a workflow is in a second, but to share workflows, to deploy workflows as REST services, to actually make them available as web apps, and more. So this is KNIME Analytics Platform. In the middle here, let me find the pointer. Here in the center, you see what a workflow actually is. A workflow consists of so-called nodes. For example, you have this file reader node, the column manager node, the partitioner node, and each node somehow is a function of on some data. For example, the file reader reads in some data, the partitioner splits the data up into two pieces, the random forest learner trains a random forest model on this data, and so on and so forth. How you compose those workflows is quite straightforward. You basically drag and drop a node from the node repository on the left to the workbench, then you connect two nodes, and then you have already a small workflow, right? In the end, you can, for example, visualize the data, you can run some statistical tests on it, you can deploy the data, you can, whatever you want, you can do with it. Okay. One important information here. The output of a node, typically if you have a look at this node, this black triangle there, this indicates that you output a KNIME table. And the KNIME table is like a standard table with some columns. The columns have types, for example, number, string, whatever. And this is the main format how we represent data in KNIME. However, as this suggests that we only can process strings and integers and other kinds of data, we also can process images, molecules, sound, text, networks, and so on. So we are pretty open to arbitrary data types. Okay, so what kind of nodes do we have in our platform? We have nodes to access data, we have nodes to transform data, we have nodes to analyze and mine data, nodes for visualization and deployment. And also we have several connectors to big data environments. And here what we do, we don't sit like in our offices and produce nodes, like 20 nodes a day, and try to increase this number a lot. No, this all comes from our community or from some of our extensions, right? And we integrate with heavily integrate with other tools, and that's why I'm here today. We also integrate with H2O. Besides H2O, we integrate with Python and R. If there's a certain functionality missing in our platform, you can simply reach out to Python or R. We integrate with things like Vector, TensorFlow, Keras, and so on and so forth. Okay. The KNIME H2O machine learning integration. So we wanted to provide our users with high-performance machine learning algorithms in KNIME. And one obvious choice for that was H2O. It's also written, H2O3 is also written in Java, and we are also like a Java platform, so this was a nice match. And B, H2O was heavily adopted by the community and well known in the field. The good thing is of having H2O in KNIME and using it in KNIME Analytics Platform is that you can mix and match H2O functionality directly with all the KNIME functionality, right? You can do the data wrangling, data cleansing, data access, data prep in KNIME Analytics Platform. Then you can reach out to all those big data environments using KNIME Analytics Platform, pre-process the data as needed, text mining, image processing, chem informatics, and do more in KNIME Analytics Platform. And then as soon as it comes to machine learning and the interesting pieces, you can reach out to H2O and let H2O do its magic. So what have we integrated from H2O? We tried to cover every aspect of H2O, but let's say we have done 90%. So we integrated all the standard stuff, right? GLMs, GLRMs, gradient boosted machines, k-means, knife base, PCA, and so on. And all this functionality is reaching out to H2O and calling some H2O function in the end. This list is a bit outdated. We have more. We now also have support for Mojos. You can read in Mojos. You can write out Mojos. You can read Mojos, deploy them on Spark. I will talk about that in a second. But this is showing most of it here. And this is a typical workflow where we actually use H2O in KNIME. What you see on the left is this H2O local context node thingy, right? If you execute this H2O local context node, what we do internally is we start up an H2O cloud in KNIME, locally on your local machine. I will talk about remote machines later, which then is used by our nodes to actually do the machine learning. The rest is just as usual with KNIME, you have those nodes. For example, the table reader node. In this case, we read in some data. Then we transform the data into the H2O cloud. We move the data over to the H2O cloud. We train some model, the H2O generalized linear model learner in this case for a regression task. And then we use the H2O predictor to make some prediction on some holdout data and do a scoring of our classification results or regression results in this case. We tried really hard to make sure that we cover all aspects of the individual algorithms. This means all the functionality you have in H2O, we actually expose as configuration dialogues to the user in a node. So if you open a KNIME node or use a KNIME node, you double-click on this node or you right-click configure, and then you can see this configuration dialog. And this configuration dialog covers nearly all of the functionality available with each algorithm in H2O. We also tried hard to find invalid configuration settings, such that the user can't do too much wrong. And we did that for each and every H2O node. Okay. To give you a real-world example, or more real-world-ish example, what you can do if you combine the two tools, I brought this Recruit Restaurant Visitor Forecasting Challenge. It's a Kaggle challenge, but this is not the important point here. It's just a challenge with some data, and we tried to build a KNIME workflow to analyze the data, and we didn't spend too much on optimizing all the individual steps like hyperparameter tuning or feature engineering or whatever. What we try to do is we try to come up with a solution, an end-to-end workflow using KNIME and H2O. So what we have is we get some data from Kaggle, and the data actually shows some properties or the number of visitors which have visited a restaurant on a certain day, and some additional information for this day and for regarding this restaurant. And what we want to do is we want to predict how many visitors will actually visit the restaurant on a day in the future. Okay, and this is the workflow we came up with. This is a bigger workflow now. It looks a bit more involved, but it can basically be divided into 5 consecutive steps: data preparation, model training, model optimization, evaluation, and deployment. And I will quickly walk you through this process that you get a better understanding how to do that stuff in KNIME. Okay, first of all, this grayish thing here, which you see, this is a so-called meta node. A meta node is basically contains another workflow, but we are hiding this workflow to avoid a too involved workflow and make the workflow more readable and understandable. So I can double-click or go into this meta node, and I see what's going on in there. And here, what you see in the first step is that I have several of these file readers, right? Can you actually see that well? Yeah, cool. So what those file readers do is I got like 6 or 7 different data files from Kaggle, and they just read in the data files, right? And here we use the file reader, but we can connect to way more data sources, all kinds of databases, big data storages, Excel files, and there are tons of formats we support. And after having read in the data, I could inspect the intermediate results, but what I also can do, I can move on and try to combine this data into one single big file. And not only that, I can also start cleaning up my data, creating new features, try to enrich it with external data, and so on. The good thing is I can inspect the intermediate results again, right? I can directly see if I create this feature, how does this look like? Does it work? I can go back and forward. I can save, load, and so on. And once I'm satisfied, I can say, OK, don't save intermediate results and go for efficient execution. OK, so the output of this bit more involved workflow is basically one large table with a lot of features in there for each restaurant, each day. Data is cleaned up, features generated, done. In the next step, what I do is I fire up an H2O cloud in my KNIME using this H2O local context. And I convert this big table in this H2O table to frame node from KNIME to this H2O cloud. OK, and now to the model training, optimization, evaluation part. Here, what I do is I train 3 different kinds of models, right? I train a random forest, I train a generalized linear model, and a gradient boosted machine. And I will show by the example of the random forest how I do the parameter optimization in there and actually train the model and select the best model. But what I do for the random forest, I nearly did exactly the same thing for the GLMs and for the gradient boosted machines. Again, I dive into this meta node for the random forest. So in this node, or in this meta node, I train the random forest model. And what I do, I have this H2O random forest learner, and I train a H2O random forest for regression. I can set all the parameters, num trees, tree depth, whatever I want, whatever H2O actually offers me. I can move on and do some prediction on some test data. And I can do that for arbitrary many splits of training test data, so I can use the cross-validation loop, which is looping over various types of cross-validation splits to create some models. I can then do that for various parameter combinations. So I can do a grid search, I can do a random search, I can do a hill climbing, and I can simply train for all kinds of parameter combinations. I can train those models, which is basically hyperparameter optimization. And in the end, I can select the best model of this entire process. I can then retrain my model on the entire data set with the selected parameter combination, and I can collect this model and output it. And I can do that for the random forest, for generalized linear model, and for the gradient boosted machine. So I can find the parameters which are best suited, so to say, for this task, for this model, for the random forest, GLMs, and gradient boosted machines. And of all of these 3 models in this case, I can extend it arbitrarily with arbitrary models as needed. I can select the best model again and convert it to a Mojo, and then I can do whatever I want with this Mojo, right? In this case, I use this Mojo to predict some cattle, to give cattle feedback on the cattle data. And I also export this Mojo such that I can use it in a different workflow or send to a friend or whatever I want. Okay, I was showing some aspects what you can actually do with KNIME and H2O, but you can do more, right? As I said, you can combine these H2O nodes with Python, Java, and R scripting if something is missing. We don't want to lock our users into the functionality we offer. They can simply integrate whatever is state of the art if they just write little scripts, Python, Java, R. And what we see a lot is actually that our users prototype something in Python, then they put it into this Python scripting node, and then they put some nodes around it, and then they use it for deployment. You can combine it with image processing. We have several use cases in the field of medical imaging, bioimaging, but also like normal imaging is becoming more and more interesting. We have integrations with deep learning, which you can directly use. What you can do is you can build networks, as shown in this workflow, which are Keras networks, right? You can use KNIME nodes to model your Keras network, which are then trained using a learner node again. You can also read in pre-existing networks which have been trained. Keras networks, and the same holds for TensorFlow. You can read in TensorFlow networks and simply execute them. You can fine-tune them. You can use them as feature generators for images or whatever, and then use H2O as a shallow learner. You can, and so on. You can mix and match as needed. You can use text processing to pre-process the data, the text processing extension, and then apply H2O models on the pre-processed data. So you can do text pre-processing and processing in KNIME, and then use the H2O nodes to do the machine learning. You can do the data wrangling and cleansing with our database integration, which allows you to do in-database processing. Data never touches your computer. You simply model what should happen in the database, and then whatever you modeled is executed in the database. And at some point, if you're satisfied, you can download the data and apply your machine learning models on that. And of course, we also have a growing big data integration. A growing big data integration, by that, it's mainly an Apache Spark integration, which means you model what should happen on your Spark cluster as a KNIME workflow, and then this is executed on Spark, right? And this can be mixed and matched again with the database integration. And we have several nodes for that. We have an integration with Spark ML. We have nodes for scoring, statistics, and a lot of data preparation, cleansing, manipulation nodes, which allow you to perform arbitrary operations on RDDs using KNIME. And obviously, this is a nice candidate to be mixed and matched with H2O sparkling water, right? So we have all this data preprocessing stuff in KNIME. We have it also for Spark, so why not allow our users to use what we have in Spark for KNIME, and then just train the models using H2O sparkling water. And this is what we do here, right? Another meta node where I can dive into, where we just load some data from Parquet. We load it as Spark RDDs, in this case again, 4 data files. We do all the data pre-processing in Spark, on Spark, using the KNIME Spark nodes, the regular KNIME Spark nodes. We do things like joining data, filtering data, column filtering, we put some SQL queries, and so on. And then, once I'm satisfied with the data pre-processing, what I can do is I can simply start up a sparkling water context. So I can start up sparkling water in my Spark cluster. So it was nicely phrased yesterday as a meta cluster in Spark. I like that. And then convert my RDD data into an H2O frame in sparkling water. And then, again, you can use the same H2O nodes, which I just used locally, to model whatever should happen in sparkling water. So you can prototype whatever you want on your local machine, use the various, then just change the connector at the beginning, and use this very same workflow then on sparkling water. In the end, after I've trained a model, I can, of course, download it and deploy it, right, as a Mojo, as a model. And then this gives me the opportunity to actually, again, use this model for scoring on an RDD on Spark. And I don't have to fire up sparkling water for that. I can directly run this Mojo on a native RDD without starting H2O sparkling water. But I can also, of course, use H2O sparkling water if I want. That's, you decide. All right. And with that, I want to thank you, and I want to thank Joe for the invitation to speak here. And I hope that this collaboration goes on in the future. Thank you very much.